So at this point, we have a function. The amount of light that my succulent plant receives, depending on where I put it in my living room, is modeled by this formula. So all I have to tell you is this is how close the plant is to my lamp. And then I'll get a number which represents, relatively, the amount of light that my succulent plant receives. Now, what I'm going to do is I'm looking for the local minimum. And in my previous video clip, we already saw what that graph looks like. There should be just a single local minimum somewhere between x equals 0 and x equals 10. Well, we know how to find local minimums. Local minimums can only happen at critical values. So I'm going to calculate the derivative of this function. So it'll be a little bit easier if I rewrite these to use negative exponents instead. So let's say I have got x to the power -2 plus 3 times 10 minus x all to the power -2. Then I can use the power rule and the chain rule to calculate this derivative. Looks like I've got -2 times x to the power -3. And to that, I'm going to add, looks like -2 times 3 times the quantity 10 minus x all to the power -3. And then I need to multiply by the derivative of the inside, since this is a chain rule formula, right? My function composition says I've got 10 minus x on the inside. There it is on the inside. Here's its derivative. My outside function is taking something to the -2 power, and the derivative of that is -2 times that thing to the -3 power. Chain rule, with a constant of +3 coming along for the ride. Now, I can clean this up a little bit and say that I have got, looks like +6 times the quantity 10 minus x all to the power -3. And this is going to be subtracted by 2x to the -3. Okay, so this is the formula for my derivative. And if I want critical values, I want f prime of x either to equal 0 or f prime of x fails to exist. So what values of x will make this formula 0? What values of x will make this formula go to infinity? Now, I know that both of these negative exponents are indicating division. So I could think of this as 6 divided by the quantity 10 minus x all cubed. And then I would subtract off 2 divided by x cubed. So I could have x equals 10. That would make this first fraction undefined, can't divide by 0. Or I could have x equals 0. That would make that second fraction undefined because I cannot divide by 0. So these are going to be two of my critical points, but remember that my f of x doesn't exist for x equals 0 and x equals 10. We saw that on the graph. So although these are critical values, they don't really make sense for this function here. Now, could we make this formula equal to 0? Sure. What values of x will make it equal to 0? We'll need to perform a little bit of algebra.